Okay, so now let's actually do some sort of examples that would show me on a test that you understand all the different subsets and definitions of all these different groups of numbers. I could just say, tell me what the whole numbers are. Tell me what the integers are. Tell me the difference between natural numbers and irrational numbers. But instead what I do is I just give you a bunch of questions and I tell you and I ask you to categorize them into the smallest set that they're a part of. So let's take a look at -5, for example. And it's kind of nice to write it in order. So the smallest set that we have, if you look up at the top, it was the natural numbers, and we write that as an n. And remember, those are numbers that are just 1, 2, 3, 4, 5. Then we have the whole numbers. So that's like a W, but there's usually two lines that start that W. And that is all the same ones, but it also has 0. And then you have someone who said the integers. Now, for some reason, that's the letter Z. I don't quite know why. Maybe it's a Greek letter thing. But the integers, that can be positive, 0, or negative. And then we have all of the fraction ones, and those are called rationals. And for some reason, that's a Q. So that's one side of it. And then, of course, the other side are the irrationals, and that's just going to be an I. So the idea is that this is the smallest over here, and it works up to the largest. And then on this side, here, there is no smallest or largest, it's just I. So, -5, is that a natural number? No, because those are only positive. Is it a whole number? No, those are positive plus 0. Is it an integer? Yes, it is. So we would say it is an integer. Sometimes we have to do some sort of reducing. So I see -8/2, I think, oh, that's a fraction. And Q's, rational numbers, are considered fractions. But -8/2 is just -4, which, yes, it is a fraction, but it's also an integer. It's not a natural. Those are positive. These are, so maybe I should write this as just to keep track of it. These are positives. These are zeros. These are positives and negatives. And then these are fractions. So like I'll put 1/2 as a kind of a reminder. But it could be negative, so I'll put -1/2. So -4 is not a natural. It's not a whole number. It is a integer. So I just put a Z. -8/5, that can't be reduced. So it's not a positive whole number. It's not 0. It's not a positive or negative whole number. It must be a fraction, and so we call that a Q. 0, it's not a natural number. It is part of the whole numbers. That's the first group that included 0. 5 is a natural number, so we'll go ahead and say, well, it's part of the smallest group, just the positive numbers. 3/2, that is a fraction. It can't be reduced. Must have been a Q then. It's not a natural, a whole, or an integer. It's the first one that's just fractions. Let's keep going here. √2. Now, if you put this in a calculator, which we don't really have, √2 goes on forever. So how would you know that, though? Well, you would know that the square root of 4, you know what that is. You should know at least. That's a 2. Square root of 9 is a 3. Square root of 1 is a 1. Those are all things you know. And if you don't know, like square root of 2, that's not one that you would know, then we can just assume that it's got a decimal that goes on forever. So it's an irrational number, I. Now you could put it into your calculator for this part, and just to double check, so the square root of 2, which the square root of 2 is going to be 1.41421356, goes on forever. Square root of 9, however, is one that you should know. That's just 3. So it looks like a square root symbol. You're like, ooh, it's going to be an irrational number, square roots. But square root of 9 is 3, and that's a positive whole number, so we call that a natural number. Now, square root of 5, -5. So square root of 5 is not something that I would know. I know the square root of 9, I know the square root of 16, I know the square root of 25. I don't know the square root of 5. But one thing I do know is you're not allowed to take the square root of a negative number. And so this one is actually imaginary. And so these are square roots of negative numbers are imaginary. So I threw that in there just to kind of keep you on your toes a little bit, but just to let you know that that's where you would see an imaginary number. And if you take, I think, second or third year university math courses, you would get there. Now this is a fraction, so I think, okay, it must be q over here. But the square root of 3 screws it up. I don't know what the square root of 3 is. Square root of 3 is some really weird forever decimal number, so I'm going to call that irrational. Whenever it's a square root of something I don't know, I call it irrational. Square root of 4 is just 2, so it's 8 over 2. 8 over 2 is 4. So 4 is just a natural number. It's a positive number like that, so I'm going to call it a natural. Wow, double square roots. I think, oh, this is going to be definitely going to be a problem. But the negative's on the outside, so that's okay. And the square root of 1 is just 1. Square root of 4 is 2, so it's a negative a half. And that must be, it's not any of these whole numbers here. It's actually a fraction, so our fractions are here, q. So I will do that as an irrational number. Continuing on, 0.7. Okay, so that's a decimal that just stops. Therefore, that must be q here, a decimal number that stops. So q, it terminates, I think is the word that we used. Square root of 2, that's something I don't know what it is. Negative on the outside is okay. So that is going to be an irrational number because it's going to be a decimal that goes on forever. Now here, this looks like maybe a pattern. 5, 2, 3, 5, 2, 3, 5, 2, 3. So you could have put a little line over the 5, 2, 3. There's a pattern there. Because you're allowed to have a pattern, that's going to be q. That's a decimal that has a pattern. So this is a decimal, m here, this is a decimal that terminates. And this is one where it's a decimal that has a pattern. Both of them q. Now this, 1, 2, 2, 1, 2, 2, 2, 1, 2, 2, 2, 2. Do you see the pattern there? It says 2 2s, then 3 2s, then 4 2s, always separated by a 1. However, it needs to be the exact same pattern. For q, it needs to have 5, 2, 3, 5, 2, 3. So this would need to be 1, 2, 2, 1, 2, 2, 1, 2, 2. But they keep adding a bunch of extra 2s in there. So we still would call that an irrational. It's a bunch of random numbers. There's a pattern to it, but it's just a bunch of random numbers. There's no definite pattern that repeats. It needs to be a repeating pattern. And pi, that's that one, as always, that people like, where it is a decimal number that goes on forever. So hopefully this is somewhat helpful. There is a worksheet that goes along with this that I would highly recommend you try, and then take a look at the answer key that is provided.